Hello there, welcome back for another HOFA-College live stream. My name is Christoph Thiers, I'm studio manager at HOFA Studios and of course tutor at HOFA-College, as you might already know. And today we are streaming again live from HOFA Studios for 90 minutes this time. And I will be talking about mixing basics. The topic is reverbs, spatiality, creating space and bringing order into all of your mixes. Okay, so this is a beginner's tutorial, a beginner's workshop. If you're already familiar with all the basic stuff, it might be a little bit boring, but at later time we will have another workshop, like a masterclass, about all those basic things. Well, reverbs and spatiality, that's a very important thing, especially in the mixing stage, but also in monitoring. We will skip all these topics about recording music. We will get straight into the mixing stage. By the way, I have the live chat, the YouTube live chat right in front of me. So if you have any questions, feel free to ask me. We only have 90 minutes. That's not much. That's why I will get right into it. Shall we? Okay, first of all, I want to talk a little bit about why at all do we use reverbs, echoes, delays, and stuff like that, time effects in the mixing stage. There are mainly three realms why we need it, or three reasons to use it, rather. And I want to look at them separately because it might be... sometimes you will need different reverbs and different tools or different approaches to that either reason. So first of all, it might be kind of obvious, natural impression of space. What I mean with that is nowadays we do a lot of close miking in recording music. So for example, if you record a drum set, for instance, you will have quite a lot of different microphones on different sources, like each tom has its own microphone or even two of them. The same applies to bass drum, snare, and so on. And maybe even the cymbals are, each one of them is kind of spot mic'd or close mic'd. And of course, we all know a drum set or whatever we record sounds quite different when listened to from a bit of a distance, in a concert space or something like that. So we do need in a close miking environment, we do need virtual space, virtual reverbs and something like that to create the sense of space. Okay, or the sense of room or something like that. And of course also the sense of direction. For example, sometimes it makes a huge mistake. It can make a huge difference if you have something right in on the right side of you and the reverbs is answering from the left side. And of course, also the pre-delay times, we'll talk about that later, what that is, will make a lot of difference in the localization of something in a virtual or if in a real room. So this is point one, natural impression of space. The second, it's kind of similar to that, but I will approach that in a different kind of way, and sometimes you would rather choose two different reverbs or something like that to actually get the direction and the imagination or the simulation of space. And the other point is the simulation of depth. Because depth, of course, is also something spatial. We all know that. Depth means whatever is right in front of you and whatever is right in the back. It might be kind of obvious, and we only need that, again, in a close miking scenario or in a overdub scenario or something like that, where you put different, maybe even virtual instruments from your computer or something like that, or individually recorded instruments or elements. If you put all of those into a mixing environment, you have to create a virtual kind of space, which is not only left-right, it's also front and back. So that's the second thing. We sometimes call it staggered depth or something like that. It's the near-far thing. And of course, it's a lot about contrasts in this realm. We'll talk about that later. The third is rather different from the first two because it's not about naturality. It's actually the complete opposite. I will call it sound design. Let's just call it like that. Sound design doesn't only mean something like, yeah, we're creating sound logos or something like that, or we're creating some virtual sounds that aren't capturable in real instruments or something like that. Of course, that's also true, but sound design will also be true for something, let's say a guitar amp, for example. Most guitar combos, like old Fender Fender reverbs or something, they have built-in spring reverbs, sometimes also referred to as echo or something like that. Sometimes these words get mixed up, especially in vintage equipment, but it's a spring reverb. It's a reverberation unit, an analog one, and it doesn't sound at all, at least from nowadays point of view, it doesn't sound at all like a real space. And we still use it though, because we got used to it. And of course, it makes a huge difference in a guitar amp or something like that. We use it before in an effect loop usually, or there are different topologies for that, but we won't get into that. We use it before the end stage of the amp, so it also has the imprint of the last tubes it goes through, and it also has the imprint not only from the amp itself, but also from the cabinet it is played through. So that's more a sound design thing, and sometimes I think the guitar is a very good example for that. But we also use it, for example, in organs. Hammonds, for example, they also use a lot of spring reverbs and stuff like that before the amp. So that's basically the three things we have: natural impression of space, virtual space, if you want to call it like that, simulation of depth, near far, and sound design purposes. There's a first question in our live chat. I see Andre Shinami asks, will today's rule apply to orchestral soundtracks? Of course, Andre, they will. In fact, these basics I will talk about, they will apply to whatever you do. Yeah, whatever you do. It might the genre is pretty much, or the stylistic you're playing in is completely. Yeah, you can use it in any type of application. Even it really will even apply on audiobooks or something like that, or audio plays rather, and of course also ADR, like film music, whatever you do. Of course, orchestral soundtracks also are very applicable here. You will see differences in what kind of reverbs you will use for certain applications. For example, let's say in the realm of orchestral soundtracks, usually you would have strings in a typical environment for strings. And strings, that's usually something from 5 to 50 people playing strings in an orchestral context, and that usually doesn't mean you're in a bathroom. You know what I mean? And that usually doesn't mean you're in an elevator. But in most cases, you will use something like a hall-like sound for that, like a concert hall, or you would use something we know historically, which comes near to that stylistic, like, let's say, a plate reverb, or maybe even an artificial chamber reverb or something like that. But you won't, well, you can, obviously, but most of the times for orchestral soundtracks, you wouldn't use the sound design thing that much, like reverse reverbs or multi-taps or whatever. Okay, let's get into it. We have two main types of time-related, time-based effects we will talk about today. It's basically reverbs and delays. There are also some special kinds, and we might talk about that as well, but mainly we'll stick to reverbs and delay. So, let's talk about the structure and the differences maybe first. I actually made a couple of graphs for you where we can look at that. Let's start with reverb, shall we? All right, look at that. Beautiful. I built that just for you. This is in a time domain how a reverberation tool, whatever it is, if it is a real space or if it is a virtual space, or even if it is something sound design related like a spring reverb, it will always act something like this. First of all, well, obviously, it's the time axis is the x-axis here. It's from left to right. So first comes the direct signal, whatever that is. For example, if you have strings, this will be your strings. If you have drums, this will be your drums. Okay, this is the direct signal. Of course, it is a time-based effect we're talking about here. So as you all know, first the strings are playing, and after that, the room will answer in some way. And what comes first is called early reflections. Actually, the name already applies what it is. It's the first reflections from nearby surfaces. Yeah. For example, when I'm talking here right now, the first, let's put a mic here just to envision it. The first early reflections from my voice will probably be the desk, of course, maybe my screens here, whatever surfaces are nearby. Okay. So the time between direct signal and early reflection might differ greatly. This means, for example, if you stand in a church, in the middle of a church rather, and the next wall is like 30, 40 meters away or something, of course the early reflections will appear much, much later than in a small cabin or something like that. And of course, they will sound different to each other just because there are different surfaces. Some of them are reflective, more chaotically reflective, and some of them are absorptive. So you all know that. There are dead rooms, for example, like vocal booths or something like that. They are usually quite absorptive, and that means we still do have early reflections, but they have a certain imprint on them. So they might not be through the whole frequency spectrum, for example. They will have a certain amount of damping on them. Yeah? All of them will have, but yeah, the kind of surface will tell the sound what frequency you will get back from it. So that's the early reflections. I made 4 of them here. Of course, in reality, it's far more of them because it's not just 4 nearby surfaces we have usually. But as you can see, you can imagine this is like the first wall you're standing right next to, and this is the second wall, which is a little further away from the sound source, and so on. So these are the early reflections. After that, the reflections will always be reflected again and again and again and again. Of course, it's not just like you have a single echo coming back from a wall and then the energy suddenly disappears. That's not the case, of course. It will be reflected again and again and again in very, very complex stages, actually. But each time it will be reflected, and even while wandering through the air, the sound will always lose energy. So over time and over time, it will slowly or maybe faster, depending on the absorption of the material and so on, you will see that it will get less energy and less energy and less energy. And this complex reflection of reflection thing going on here is called a reverberation tail. So the difference is, and of course, technically seen, physically seen, it's not that big of a difference, is it? We have early reflections, which are reflections coming direct answers from the nearby surfaces, from the sound source itself. And after that, we have a complex pattern of reflections. And that's called the reverb tail. So why do we make a difference here? Well, it's kind of simple. The reason is in big rooms, when the delay time is big enough and you're far away from the wall, you will be able to hear those early reflections in a distinct way. It will be distinct from each other, or it can be at least. And the reverberation tail is, per definition, a an indistinct pattern. All right, it's so complex and it's so many reflections melted into each other. We just hear something like you can't tell which is coming from where and so on. So that's basically why we make a difference here. And also, of course, the height of the corresponding line I put here corresponds to the volume. Obviously, I think that's kind of obvious here. So the direct signal is usually the sound source makes some kind of sounds, and of course the early reflections will be a little later, and also a little duller, and also a little less energetic, right? A little quieter. Same applies to the reverb tail. Over time, with each iteration of reflection and so on, it will slowly lose its energy. Okay, that's basically the structure of a reverb. It's quite simple, isn't it? There's another one. Let's talk about delay real quick. Delay, or sometimes referred to as echo. It looks something like this. Basically not that much of a difference, is it? Well, the biggest and actually even the only real difference here is we don't talk about early reflections. We just leave that out. And we still have a direct signal, same thing as before. And we have a huge tail here. But as you can see, there's far more space between the lines here. So, and there's enough space so our ear can tell there's not a indistinct pattern here. So instead of melting together as a big tail like we have repetitions. Slowly decreasing in volume, or maybe faster decreasing in volume, whatever. There are parameters to control that, of course. And also, most of the time, not always, but most of the time, usually each iteration, each repetition of the initial direct signal will not only be later and quieter, it will also be duller. Actually, same thing applies as to reverb. The biggest difference here is that we have distinct repetitions instead of an indistinct, melted kind of reverberation tail. All right? So this is the structure, and this is the basic differences. Not that big of a difference. And we'll talk about the parameters in virtual effects we have. Of course, reverbs and delays, how to implement them in your mix, and how to control and how to use it for, the three reasons we already talked about. Okay, let's get on. Well, first of all, as this is a basics, mixing basic workshop, I want to start talking a little bit about the implementation of those reverbs. I just pulled in some tracks here from a pop rock music session here. It doesn't really matter. This is just as an example. It's not really mixed, but we will do a little bit of reverbs and rooms today, of course. So, how to implement reverbs or / delays? Okay, let's start with reverbs because it's much more obvious, I think. This is the drums, the dry drums. They already have a little bit of room on them. That's just because they were played in a room, obviously. So first of all, this is the closed mic signals all together. And I have the option, as a recording engineer, I have the option to choose the suiting room for the drum set or whatever. And especially something that with like a drum set which has as much kinetic and sound energy like a drum set will have a huge difference and a huge impact on the room sound, of course. So I can put a couple of microphones around, like, to capture something like that, which is already a natural reverberation tail in itself, or something like that in stereo. Different mics, different positions. So this would be the first thing. Especially when recording in big rooms or like if you're talking about orchestral soundtracks like we had before with Andre's question, recorded in a big room with a real orchestra or a big ensemble or something like that, you are able to pick the room and choose the right suiting acoustics and put out some microphones. But what if you haven't? Or what if these are virtual instruments? Let me just pull down those faders so we can only work with the direct signals of the drum set here. Okay, sounding like that, let's put some reverb on the drum bus, shall we? I'm gonna just choose our own algoverb, it doesn't really matter which. Okay, first thing we will notice, woo, there's just reverb, no direct signal. There's a little knob up here, dry wet knob. I think most of you know it. 0 wet means only direct signals, 100% wet means that's just reverb left. So, of course I could do it like that, no problem at all. But now my other instruments, if I pull them there, okay, they are completely dry, so they need their own reverb. Okay, let's pull that over then. Whoop. Each has its own reverb. Same applies to the guitar. Okay. Over time, in a big mixing session, this will get quite tedious. And of course, if I choose a different setting here, then I chose here, it might be a little tedious to always hunt after that. And also, many reverbs, especially those more traditional or analog effects, don't really have much options of controlling the sound of the reverb. So you will want, oftentimes at least, you will want to control whatever is going into the reverb. Frequency-wise, for example, maybe you want to put some de-essing on it, so the S, like the sibilants from vocals, for example, doesn't go that much into the reverb and comes back from the room or something like that. And even the return from the reverb, you want to be able to manipulate that as well. Like you could do creative stuff there, like ducking or compression or saturation or something like that. But even far more simple things like controlling the frequency response, so it doesn't get in the way of the dry vocal or something like that. And you're not really able to do it in this chain, are you? Because you have a reverb inserted, and let's say here on the guitars, for instance. And of course, I can put an EQ after that to pull out some, let's say 2K. I want less 2K in the reverb, but that's not only applied to the reverb, but of course also to whatever else is on that channel. And it's not just the reverb, it's also the dry signal, and actually quite a lot of that. So, and also it's not very CPU efficient either, because if I do it even without buses, in the end, with 96 tracks, I will probably be ending at 96 instances of a reverb. And whatever CPU you got, that's probably a little much for most computers. So I will remove those. Usually you would use in send effects. I think most of you already know it. You have insert and send effects. So I already pulled something up here, which is a pure FX channel. There's nothing on there except of, let's stick to reverbs first. Okay, there's nothing on here except of a couple of instances of different reverbs. All right, and they're all turned off right now. We can compare them later, maybe a little bit, and watch the different parameters they give me. For the moment, I will just pull on the first one, and it gives me the same options as any other reverb as well, but there's no other sound than the reverb on that channel. And that's actually quite cool, because I can copy the signal here from the drums, for instance, send a little bit of that to the reverb, and I can control that send level. And it has no effect whatsoever on the dry signal at all. I also, most DAWs at least, I also have the option here to pan the reverb differently, the reverb send. Well, so if I do it like that, I will have a little less reverb sent coming from the double drums here, going to the reverb, and it will only appear on the right side. Usually you'll keep it in the middle, but you have the option. And but the thing is, I can not only do it with the drums, I can also do it with the bass. Maybe a little less reverb sent from the bass, and of course the guitars as well, and so on and so forth. So very efficient, one tool, one reverb channel, and I can use whatever channels I have to go onto there. Of course, I also have the option to use two reverb channels. And I also can use them interchangeably, like, and also I can also stagger them actually. So in this option, in this DAW, in Studio One, you don't have the option going from FX channels to another effect channel, but I could also use a normal audio channel or a bus channel or something like that for the reverberation, and I can also send one reverb to another reverb and so on. So I have a lot more flexibility like that. And as I told you, I could use, for instance, let's say a de-esser or whatever I want right before or after that reverb, and it would only affect the reverb channel, not the dry signal whatsoever. So very mighty, very efficient, and very handy to have that option. And again, I can choose different levels for each individual track or bus going into there, and also different panics. Let's talk about that as well. I have the option to turn this on pre-fader or post-fader. All mixers have that, or at least all DAW mixers I know have it. Usually effect sends are chosen to be post-fader. That means if I just keep that to 0 or to whatever I have, it will have the exact same. Yeah, let's put it on 0 here actually. 0 dB. So this is unity gain. So whatever level I choose for the drum bus here, going through my master channel, will be the exact same level that is sent to the mixed reverb. That means if I pull down that, the reverb will not get any signal from the drums. That's post fader because the channel fader has an effect on the send channel, right? I can also choose pre-fader. And what that does, it is sent before my channel fader. That means even if I pull down that, you will still hear some reverb from the drums. See? Usually in, let's say 99% of cases, you will want to send post fader. That's why it's the default in most DAWs. You will just choose whatever level you want here. And for example, if I have an automation going through the song and I say, well, here at the end, my drums are getting quieter and quieter, it will also affect, with the exact same amount, this will also affect the reverb channel send. And of course, this means that the ratio between the dry signal and the wet signal, the answer of the room, will not change at all, which kind of makes sense. Of course, you can change that whenever you like. And you can also, completely independent from that, actually, you can do the same thing with the reverb channel as well. So you might want to bring up the reverb return in the end here. You can do that completely independently because the drum channel doesn't know anything of that, to be honest. Okay. Let's remove those again. The same applies to delays, but we don't have to go through that distinctly. Okay. So that's how you put on sound effects. It's exactly the same no matter in which DAW you are. And of course, this comes from analog times. If you had one, let's say, spring reverb in your rack, or you had one chamber or something like that, you wouldn't be able You could use it as an insert effect. Obviously, you could, but only on one channel at once. And it's a lot more practical to use it as a send effect, so you are able to send different signals to the chamber, whatever. Okay, there are also other time-based effects. It's not just reverbs and delays, but we'll go through them real quickly because actually they can sound quite different from each other, but technically they are very, very similar. Let's one is the chorus, for example. The chorus is actually a little delayed signal with most of the times it's not just delayed, but you also have a so-called LFO. You see blinking here according to the speed I choose here. And this affects how the delay time from the delayed signal is variated. So this says it's called chorus because it's like a vintage and cheap effect to get something like a doubling effect. So make multiple voices out of one. And very, very similar, but not quite the same is the, let's go on with the flanger. Much more extreme effect. Let me show you this real quick. Well, very, very artificial, nice effect. To be honest, in mixing you don't need it that often. And you could either use this for sound design purposes in an insert, but you could also use it to slightly variate and modulate your reverb returns or something like that. But flangers are not that common in the typical mixing stage, especially not with orchestral soundtracks or something like that. So flanges technically is basically the same thing as chorus, but there's a big difference. It has a feedback. That means whatever comes out of this effect box will be fed right into it again. And if I put that to 0%, it won't, of course, obviously. It's zero feedback. And then, let me pull that up here so it's a little more obvious. It has some effect, of course. It's called a comp filter here. You will find something about that in the course, of course. The more feedback I get, the more extreme this will get. And if you wonder, I can also pull it below 0%, which is basically the same effect. I'm pulling it upwards, but it's phase switched. See, sounds basically the same, but it's phase switched feedback. Okay, and of course, otherwise it's the same thing here. We have an LFO, the same thing. There's another one which is very, very similar to that. Real quick, this is the phaser. Technically seen, this is not a delay here. It's an all-pass filter, so we don't have the exactly the same delay amount or phase shift amount on each frequency. It's different and frequency dependent, so it's a little of a different effect, but basically the same idea behind it. You have LFO speed. In this particular instance, you have not only feedback, but also a color in the feedback, which is basically an EQ in the feedback chain. But other than that, basically the same thing. And you will see that depending if you use bigger delays, longer delay times, you will have a more natural and more echoey effect. And if you choose very, very short delay times, you will have something like the flanger, for example, which has massive influence on the sound of the dry signal itself because of that so-called comp filter. All right, so that's the other time-based effect. You can put that all into one thing and call it modulations. But that's, we might all agree to it. It's not about reverberation. It's not about simulating rooms or echoey environments or something. That's purely sound design purpose. So we will skip that for now. All right, let's talk about reverb parameters. how to use it, which parameter is for, and how they look in different devices. I brought a couple of pics here, and we can quickly go through them. How a reverb can look like. Maybe I'll just have zip and you have a look in this device and see if you can tell what does what. Okay. The reason why I go through those devices is because I want to show you that they can all look and of course sound very, very different from each other, but they all have the same basic parameters you can play with. And if you understood one reverb, you will, at least from my point of view, you will be able to use all of them. So let's start with this really simple one. It's a guitar pedal, obviously. And you have, let's start with a simple one, level. Loud, quiet, all right? How much level do you want? Decay is the time needed until the reverb tail disappears. This is just one of many parameters which has a lot of different names. It can also, sometimes it's called time or decay time. Sometimes it's called reverberation time or something like that, or length. All of that makes sense. And sometimes you always see the more technical term RT60, which stands for reverberation time 60, and 60 means 60 dB. So they just measure more precisely the time when the reverb tail is 60 dB quieter than where it started. So all the same, length. This is how long is the reverb tail gonna be. We have here, let's go on with tone. The guitar players of you all know it. We have many guitars and many guitar amps have some kind of tone. It means bright or dull, basically. It's an EQ. And what kind of EQ? Where the cutoff frequency is, if it's a cutoff or if it's maybe it can be a bandpass or whatever. You don't know. It doesn't tell you, but you know it will do something with the frequency response of the reverb you have here. And we have another one you can see in every single device. It's called pre-delay. Delay, of course, it's the time needed from A to B. And I will show you what pre-delay is in my little structure here. It's basically from here, direct signal, to here, early reflections. The time between those 2 points is the pre-delay time. And as this might seem really, really simple, it is very, very important to understand how to use pre-delay. Pre-delay has a huge impact on if a signal is perceived as near or as far, as in your face or as very, very far away. Obviously, level has as well, but actually one of the mightiest tools you have to put something back into your mix or pull something out of your mix in your phase, it will be this time needed between direct signal and room reflections. And how do we use it? Maybe we should go back to the idea of standing in a church, shall we? So imagine you stand in a church and you clap your hands, okay? So there's, if you're in the middle of the church, you will need a lot of time. The sound, of course, will need a lot of time from your sound source, your clapping hands, to the next wall and back to your ear. If it's 30 meters, it will need all that time, 30 meters there, 30 meters back, 60 meters of time, okay? If you're standing in a smaller room, 2-3 2-3 meters or something, you will have the same reflections a lot earlier and a lot louder as well. But of course, most significantly, a lot earlier. And so the pre-delay time has a huge impact on whether the room you're standing in is perceived as big or as small. And also, as I told you before, it has a huge impact on whether the sound source is perceived as near or far. Imagine the same church, big church. If you clap your hands right in front of my face, from my point of view as a listener, the sound source, the dry sound, if you want to call it like that, will be much earlier than the reflections will be. That's because the distance between my ears and your clapping hands might be, I don't know, a meter or something, and the sound of your clapping hands going through the wall to the wall and back to my ear is, let's stick to 60 meters in total. But if you're right in the back of that same church, on the far right corner, let's say, and I have the same position, the difference, the time difference from the reverberation tail and the early reflections coming from your source and the time needed from the direct signal from your clapping hands to my ears will be more or less the same, right? So if you want to write down anything in this workshop, you should write down this. The smaller the pre-delay time is, the shorter the pre-delay time you choose, the further away the direct signal appears. Okay? So basically, coming back to my mix here, I could easily copy that whole channel, right? Oh, let's just do it like that. We could simply choose the same settings. Just one minute. Whoop, 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 whoop. Add effects channel here and maybe one for the bass, okay? And we can use exactly the same settings from all the 3 reverbs. And the only thing we change will be the pre-delay time. See? And I can call that reverb far. See if that's the right one. Yeah, pre-delay 0 milliseconds. Reverb mid. Let's say 20 milliseconds, whatever. Seems suitable. And maybe 50 milliseconds for reverb near. See? 3 times, same room, different pre-delay times. And now I can basically choose where my instruments have to be put in the mix, right? So my vocals, maybe lead vocals, should be right in my face. So I'll send them only to reverb near. Maybe I have some guitars in here as well. I would send them to the same reverb settings with a little more pre-delay time. And they will appear in the mid, on the second layer, you can call it like that. And the drums maybe right in the back. And of course, I don't only have those 3 layers, because I also have the option to pull one onto 2 of them. So what will happen if I put it on? That doesn't make much sense here. Let's choose reverb far and reverb mid. So the ratio between whatever I send from that individual channel to the reverb far, my farthest layer, and to my mid layer will result in the perception of where my signal is between those 2 layers. See, it's that simple. So if my goal is to have a natural impression of space, a sense of natural room acoustics, I can easily choose just one reverb setting that seems suitable for me, and I just copy it 3 or 4 times. You can basically do it a lot more, obviously, but usually 3 is more than enough. And simply just send all my signals to one of them or maybe two of them at once. Okay, that's the pre-delay and what it does. Diego asked, is the same workshop as tomorrow? Yes, it is, but the workshop tomorrow will be the same, or more or less the same, but in German language. So if German is better for you, wait until tomorrow. Okay, what else do we have in almost every reverb? We already saw the tone here. It has some impact on the frequency response, as we already said. We have another one here. We have an EQ here. We have a distinct manipulation on early and late. So this is early reflections, and late is another word, yet another word for the reverb tail we talked about. And I have the same thing here, high cuts. I have EQs here, high cuts, low cuts. See, it's always the same. We have a mix knob, which is quite obvious, I think. We have the pre-delay time, which is one of the most important factors here. We have the decay time, length, whatever, always the same. Decay. This is just reverb, it's called. The decay. See, it's always the same. Usually, or in the more simple reverbs, you will only have a high cut, which is also sometimes referred to as dampen or damp. That's because it's just natural. Usually, low frequencies are, everyone who ever built a studio knows that, low frequencies are not really bothered by most absorptive materials, at least not if they're little. But high frequencies are already absorbed by tiny amounts of absorption or even diffusion. So in most natural rooms on Earth, you will have some kind of high cut or dampening going on. As I told you before, the reverb tail will usually not only get quieter and quieter, it will also usually get duller and duller. But of course, theoretically, it could be the other way around, but there are not many acoustic environments in where the low frequencies are absorbed and the high frequencies aren't, or as much. What else do we have here? Mix, pre-delay, decay, high cut. All right. In this particular reverb, we have something called depth. And what this does, actually it's shown down here, controls the perceived distance from the source by adjusting the balance between early and late energy. So basically, it alters the ratio between those early reflections and the reverberation tail. And of course, when it comes together with the correct dampening and reverberation time, and of course pre-delay time and a correct amount of reverb, this will lead to, as said here, a perceived distance from the source. Kind of obvious, I think, if you again think of the church example we had before. That guy clapping in the right, left corner, whatever, in the back of the church, and you standing there in the middle. Whatever energy is coming from his hand clapping to the nearest surfaces around him will not only appear almost at the same time as the reverb tail and the dry signal to your ear. It will also be through that same difference, same distance, it will also appear roughly in the same loudness. And of course, obviously, if the clapping appears very, very near, the early reflections will be a lot louder, because the lost energy will only appear later when the reflections are reflected again and so forth. Okay, so, and of course, obviously, if I pull that down to 0, I will only have early reflections. Only early reflections, no late reflection, so no tail at all. And this is something which is quite clever and not so obvious in most cases. That's a little trick maybe. You can use reverbs with only or almost only early reflective patterns to put something, especially something which was recorded too dry or something which comes out of the box, something like a virtual instrument or something without any room information. You can put that into an perceived space without muddying your mix if you only use early reflections or mainly early reflections. And some reverbs, as this one, for example, give you the option to manipulate the late and the earlies independently. So I have something like a bass multiplier, and this is basically whatever multiplier you put in here is multiplied onto the decay time, more or less. So if I choose a bass multiplier by 2, the bass frequency will decay. Bass frequencies will decay much longer than the high frequencies. Obviously, the same for the highs. And I also have a crossover frequency here, which I can choose from just to define whatever is bass in this instance and what is high frequencies. In many reverbs, you will find something like this, which is called size, which of course refers to the room size of the virtual room. This does multiple things at once. It has an impact on it usually has an impact on the pre-delay time, but most importantly on the length of the reverb tail, which is kind of obvious. Big church has a much longer tail than a small church. It will also, in the algorithmic material behind it, it will also have an impact on how that pattern is achieved. So try and clap in that big cathedral. You will see that not only there's a long reverberation tail coming quite late after your hand clapping, but it will also need some time to build up. That's because reflections of reflections need some time before they become, just because of the big distances, they need quite a bit of time to get into that reverb tail area where they all melt together to be perceived as one. So it also has an impact on that, and obviously, or mainly on the early reflections as well, because in a big room, the first walls, maybe you're standing right next to one wall, okay, so that reflection will come early, but the others are farther away, so it will have a huge impact on the pattern of the early reflections, when they come and how loud they come. So the perceived size and the perceived distance of a sound source is actually a combination of all of that. If you try to achieve it with just one parameter alone, you will have loads of problems with that. Obviously, width is referring to the stereo width. Kind of obvious. It's just more or less the differences between left and right channel. We have an EQ here, and we have in many reverbs, because especially algorithmic reverbs, you have something called mod, which refers to modulation. It's basically, usually it's some kind of phase shifting or rather pitch shifting. So with rate, it's basically an LFO, so 2.5 times per second. This will modulate the frequency of the reverb answer, and that's basically what we have. And you will see those in almost every reverb tool you have. See, width, mix. Here's something new. Pre-delay, size, damping. As I told you before, damping is just another word for the high frequency. Usually it's a cutoff or a sometimes also a shelf, but doesn't really matter, to be honest. It has an impact on the frequency response of your reverberation. This is something new, something which was originally never built into any reverb, but became popular in the 80s. Listen to songs of Phil Collins and so on, and you will hear a lot of gated reverbs on snares. So after that, many manufacturers chose to build in a gate into their reverbs as well. So what this does, I guess most of you already know a gate. Well, you choose a threshold. Whatever is below that threshold will not be audible. Whatever is above it will be audible. Quite simple. You use it to have less bleeding on snare tracks or whatever, and you have a release time for how fast that gate closes. Very simple effect. And in this particular use, you would have the gate on the reverberation solely, but it will be affected by the dry signal. This means, let me show you it with maybe only the snare top, which is, as I said, like the standard use for it. Did I call it reverb far? I think. Yep. So this is reverb with this is snare with reverb. If the threshold is chosen too high, so the snare is below it, we won't hear the reverb at all. If I choose it too low, I see it's quite quiet, that thing. So I can use that to only have to listen to the reverb while the snare is playing. So if you choose the right settings, maybe not with this reverb, it's not the best, to be honest, but it's just whatever is the first you will find in Studio One if you search for reverbs. See, you can build a virtual room which disappears according to that gate. Very artificial. It can sometimes be used not only to make a virtual room, but rather to thicken up a snare. Something like sometimes I use it instead of adding another snare sample on top or something like that. So you can play around with that. But gates, no typical thing for reverbs, but some have it. Let's have a look at this one. Okay. Basically another standard algorithmic reverb, which looks different. And this is, I think that's quite good for beginners, because you actually have a visual representation of the room, of the virtual room you're in. So the green one here, it says it's the listener. And I have two sound sources. If you wonder, that's left, right, of course, it's a stereo channel. And behind that, it's just pure mathematics. Yeah, it's an algorithmic reverb. So we have it's just math, which does the reverb. So you have a couple of parameters you can control, and that's not just what we had before, but in this particular algorithm, you have the opportunity to manipulate the distance from the sources of each other, the position in the room, and also the height. You see that little point here going up and down. Dampness, we had that before. Reflexivity, it says. Reflexivity, it's basically the amount of reflection coming back from the walls. It can mean how many of them, so how complex the surfaces are. It can also mean how much energy comes back. So or reflexivity as the counterpart to absorption. Population, Well, if you have many people or whatever in the room, let's say if you have loads of furniture in the room, it will sound dramatically different. So this is whatever is going on in the room. This is an empty room. Same room with a lot of what else? Furniture. Pre-delay, length, mix, size, width, height. This is quite uncommon, but in algorithms like that, you also have the geometry of the room you can distinctly change. Very often you will find the opportunity to change the type or algorithm behind it or the behavior of the room. They sound different, of course, and they also have an impact on, again, how fast the build-up appears, how maybe sometimes even on how the EQs are built and so on. But basically, you just choose whatever appears to be suitable. So if you want a medium hall, a large hall, or a small room, and you start from that and change the parameters according to your wishes. Well, that's basically what we can see here. Let's have another one. Okay, this is a completely different technology to achieve reverberation. Obviously, math is always involved, and it would be far too much for this basics workshop to go far into that. But this is called a convolution reverb. So basically, what this works on is actually sound samples. So you have a sound recording from a real room, or maybe from a plate reverb or whatever reverb you have. It can also be manipulated and so on and so forth. So behind that, you choose with that button, for example. It doesn't load an algorithm; it loads real audio files. And you have a representation of the waveform as well. So, for example, you can see here there's less and less and less energy, and suddenly there's a jump up, jump up, jump up, which is more of an echoey pattern. So, what convolution does, it convolutes the aesthetics and the characteristic of a reverberation, or it might also be an EQ pattern or whatever you have onto whatever sound you put into it. It's quite CPU heavy, but it has, from very early on, engineers had the opportunity with this technology. When it was invented, you had the opportunity to, for the first time actually, to have real rooms without being there, being convoluted onto whatever source you have. And that's quite mighty, and convolution reverbs are therefore perfect for natural reverbs or for capturing whatever reverb pattern you like in a real room or from some device you borrowed from a friend or something like that. But basically, starting from that point of loading the room you like, the IR you say, it's an impulse response. Starting from that point, you have very, very similar parameters to choose. Let's pick some of them. We already know pre-delay, same thing. Length, same thing as before. The technology behind it is a little different than in an algorithmic reverb, because here the impulse response gets stretched and then convoluted, but it's basically the same what we had before. Okay, gain, simple gain control. Something which is called early reflections and late reflections, ER, LR. Can we zoom in here a little? As you can see, this controls the ratio between the ERs and LRs. As I said before, sometimes you don't want a lot of reverb, but some of a little spatial context, let's say. So to make virtual instruments appear a little more real. And you could maybe just choose only early reflections for that. So if you have the opportunity to use those alone, it's a great feature. Mix, we already know that. We have an EQ down here. Self-explanatory, I think. We have something called crossfeed. That's good. Of course, this is a stereo channel. And whatever comes in to the left channel and whatever comes into the right channel might, depending on the reverb, some are true stereo, some are not, but let's not get into that. Usually in a stereo reverb, you will have a different outcome if you send something into the left channel than into the right channel. And these can be very similar or very different depending on whatever you choose to mix into that, right? So you have a crossfeed to crossfeed those inputs. And yeah, cross delay and asymmetry is basically has another impact on that as well, obviously. But crossfeed just means whatever is on the left channel will also be fed a little bit into the right channel as well. So which also has an impact on the perceived width of a signal, because imagine you have, let's take a string quartet right in front of you, right in your face. You will have the cello on the right side, and on the very right side, appearing only on your right ear or almost only, and the first violin on the left side. Yeah. The further you go away from it, the narrower this field will appear, right? It's just natural. Yeah. The difference between left and right is, the further you are, it's not that big anymore. So with that crossfeed, you also, if you have that parameter, you don't always have it, but if you have the parameter, you also have some kind of influence on the perceived width of the, and therefore depth of the direct signal and the reverb mixed to it. Okay, envelope, that's all of you people playing around with synths, they know envelopes like ADSRs and so on. This usually will only appear in some convolution reverbs, and it's basically, yeah. Let's pull it up, and you can see whatever it does. It's basically affecting the level over time of your impulse response before it is convoluted onto your direct signal. That's it. All we can do here. Mighty tools. Let's have a look at another one. Looks different, has the same options, right? We have a couple of algorithms to choose from. We have a vintage button, which, if you choose that, well, enable tooltips, it'll say you what this is. It just has a lower sample rate, yeah, a vintage mode, let's say. Of course, you have presets, obviously, and you can change the amount of early reflections. 100 is obviously like the standard, the default. You can turn them off. You can double the energy of the early reflections. You have a size parameter. You see here. It's depicted as a width of the line, but basically, as I said before, size usually has impact on the patterns or the behavior of the algorithm, on the build-up of the reverb, on the delay times between the distinct repetitions and so on. Gain, obviously, loud, quiet. Again, you have something called mod, rate and depth, with a funny visual representation of this thing. Just to make, this is especially helpful on simpler algorithmic reverbs, to make them appear a little more alive, a little more complex than they really are. Again, you have a gate option, turned off right now, turned on now, threshold, hold, and release, just typical dynamic feature. I showed you that before for your Phil Collins snares or whatever you have. Usually you would have that off. You have a decay time. how much diffusion is going on. That has basically to do again with the dampening of the room. Before that we had, I think it was here, yeah, we called it reflexivity and population. Basically all similar things. Of course, as there are different equations that calculate it, we sometimes have different inputs to choose from, but it basically is the same. So 0 diffusion would sound something like that, and 100. So the less you have, the less chaotic and the less reverb tail-like the results will be. And of course, one of the most important things, pre-delay. Also, we have something which we already saw before. I think it was here in the, I forget that. In the Valhalla screenshots I showed you before, we have something called a multiplier. So as you can see, this is how long over time, so the y-axis here is time, how long the low frequencies and the high frequencies, the mid frequencies and so on will reverberate, and also cutovers for the same thing here. Quite basic. It's not the same as an EQ, because it basically says how long the time will, how long the tail will be in that frequency area, and not how loud the tail will be in the area. So it's something different, in fact. And let me just show you it for a sec. See? Very hissy, very tight, a little more boomy. And also we have, in this case, we have an EQ, which is basically just 2 filters. High cut, low cut, that's it. And of course, mix wheel. And let me show you our most complex and most recent reverb tool. It's the IQ Reverb version 2 now. This also is a convolution reverb, which I said is very, very suitable to have very, very different results, to load in your own samples and impulse responses, and especially suited for very natural sounding reverbs. You have a big library here, which you can, where you can just choose your room. Let's say I want a plate and a rather long one, maybe. I'll just choose my filters here. Oh, that one sounds good. Or maybe mid joint. Okay. Now I have loaded that that sample here. I have a visual representation of it, and again I have basically the same parameters as always. In this particular case, we have up to 4 reverb loader, like impulse response reverb loader, and we also have them combined with algorithmic reverbs. So in total, I can mix up to 6 reverbs into this one in one instance, which of course is a little bit overkill for most cases, but well, you can just switch them off if you don't need them. And they can be very handy if you do something like surround mixes or something like that, where you sometimes want some different reverb for the back than for the front and so on. You also have a couple of usual effects built into there, which you know from usual mixing purposes, like EQ. But even if I chose to load this one as an insert, this would only affect the reverb. Of course, I can stretch that convolution, so I can influence the reverb time, the perceived size of the room, the pre-delay time. I can swap around left and right. I can reverse the whole sample. That sounds funny. Is there going anything into it? See, very unnatural, of course, but you can use that for sound effect purposes. Yeah, I have an EQ here, which is applied on the convolution on the impulse response before it is convoluted. I have an envelope again. We already saw that in another instance. I can do funny things like that. Echoey patterns if I like. I have an IR cut, which has a similar effect than as a gate, but to be precise, it's not the same because I can choose a concrete number here. So after 1000 milliseconds, it will fade out over 50 milliseconds, and it has a similar result as a gate on a reverb, but isn't triggered by anything, so I have more control. Modulation, again, we had that a positioner, which makes a lot of sense if you want quick and easy results in an insert channel. So basically this X is where you put your sound source in the virtual room. So I can mix it right, left, near, far, and obviously this will affect many parameters at once, like pre-delay times and all we talked about earlier. And also insert effects like saturators, compressors, gates, and so on, like to manipulate this reverb sound. But as you can see, it looks kind of complex maybe for the beginner, but basically if you know one reverb, just start by searching for the same parameters you already know. Like, where's my level? Where's my mix? Where's my reverb tail? Where's my early reflection? Where's my pre-delay? Where or how can I change the frequency response of my reverb, and so on and so forth. Quite simple, huh? That's basically what we use and how we use reverbs and their parameters. We have about 12 minutes left, I see. So let's talk about delays as well. Delays is basically, as we saw earlier, it's basically technically the same structure, or nearly the same structure as, well, that looks funny. Weird. As we had in the reverbs. It's basically the same. We have a direct signal, and after that we have a repetition and a certain pattern of echoes and repetitions of that might be changed in sound and of course in time, obviously. Let's start right here. This device is called a beat delay, and most DAWs I know have something like this built in. Obviously you have a feedback. Feedback, again, is whatever comes out of the unit will be fed into it again. If you choose a high feedback, it will, depending on the particular device you use, it might be that it gets louder and louder over time. Well, it might be handy to send something in there, otherwise we can't hear anything, obviously. See, in this case, the developer of the plugin chose to make 100% of feedback just as loud, so it will stay almost, it will get quieter and quieter over time, but it will not get louder and louder, so it would hurt your ear probably if he hadn't chose to do that. Well, that's the feedback. Obviously, if I turn it back, the delay will stop rather soon. Beats. It's just a delay time, depending on the project tempo I chose. Kind of obvious, I think, so this will be a 16th echo and so on. I can also offset this, so it will appear, let's say, 16 milliseconds before that 16, so it will be a little upfront or a little laid back to make it a little more organic, or what's not. We also have a color, it's called here. It's basically what we had before, and it was called an EQ, and it was called high cut and low cut, it was called tone, whatever. It's always the same, basically. You have different kind of filters and bells, but shelves and so on in this, but yeah, it's a frequency response, obviously. And we have again something called modulation, which is a bit more complex in this delay cases most of the time than it is in reverbs, just because it's more, it's a little clearer what it does, and it's a little more obvious, and you just need more of it usually in delays than you do in reverbs. Width, difference between left and right. Again, cross delay. So in what we have before is cross does always mean something has something to do with the left and right channel. So in the cross delay means it's the time difference between the left and the right channel. This can also be quite handy to make the for example, to make mono sources to appear more stereo, something like that. You have a ping pong option. I really love that word ping pong a lot because it brings a pic into my mind, a picture, and it's quite funny if you see it like that. If you watch a ping pong match, I will go like this, right? So the same thing applies to a ping pong delay. It will have iterations and repetitions alternating between the left and the right channel. Let me demonstrate that real quick. You will have the first repetition you will have on the left side, and then on the right side, on the left side again, and so on and so forth. So that's a quite funny factor. In fact, that ping pong is also, depending on the technology used to achieve that delay, it might have a little different results. Sometimes it refers to, as I just said, we'll just pan the first repetition to the left side, the second to the right side, and so on and so forth. But in this particular case, I think it means the difference between the left and the right channel. So there will always be both repetitions on the left and on the right side, but they will be shifted in time against each other. But basically, it has a very similar effect. Mix knob, that's it. Obviously, I think I skipped that very basic info before, but in case you don't know, if you're using a send channel and a distinct FX channel for your delays or reverbs or whatsoever, you will always want to use that mixed knob on 100%. Otherwise, you will simply lose control. If I have it on 50%, obviously, I will have my snare or whatever, my dry signal on its channel going through my master, and I will also have on my FX channel, I will have a mixture between 50% of my dry signal and 50% of my delayed or reverb signal or whatever. So that makes you lose a lot of control. So please, when using send effects on a send channel, always put it on 100% if you're not 100% sure you want to do it for whatever reason another way. Okay, let's have a look at a few other tools. Analog delay. This looks kind of funky, but basically same options here. Obviously, this goes back to some hardware device, which looks like something like that. It's not exactly the same, but a little condescend of that. Okay, so what do we have here? We have a time factor, the delay time. We have a feedback, always the same. I have a boost knob to make that even louder. I have an LFO, which is basically modulating my, in this case, tape or virtual tape or my virtual tape delay, but basically the same modulation principle we had before. We have a color section, which is low cut, high cut. We already know that. Here we have something which is very typical for tape delays. It's called drive knob, so the amount of distortion or saturation applied to the delay. Here's something which is a again affecting or simulating the behavior of this virtual tape machine here. It's basically, well, modulating the behavior of the motor to make it less precise or more alive, which is basically the same thing. Width does, yeah, we already have that. I can swap the sides. I have a ping pong mode, and I have a dry wet knob with a lock button, which I'd usually click if it's on, as here it's on its own channel. So either you put it on 100% or you simply press locked, so you don't have any dry signal on that track as well. What is that? Oh, cool. This is they call it a groove delay, but usually you call this a tap delay or multi-tap delay. This also goes back to tape delays. If you roughly know how a tape machine works, it's basically obviously the tape running around and passing by one or multiple, as in this case, tape heads that read off that material. And in a normal tape machine, you just have one head, which is listening to whatever comes by on that tape, right? And on a multi-tap delay, at least in the original tape realm, you'd have, in this case, 4 heads. And they can be physically moved. So the physical distance between those heads and therewith the time amount needed for the tape to pass between those heads can be chosen. See? So that's where multi-taps come from. Of course, this is also doable in analog or digital electronics by simulating that behavior, or to just drop into a bypassing stream of audio. I can choose the position here. This is now gridded to whatever note I want to choose. I can choose a position here. I can alter that. I have that's really cool and comes from the tape multi-tap as well. I have a distinct feedback knob per tap, which allows very, very complex and weird and funny patterns. This is possible because each tone head, each tape head has its own distinct output, right? So I can put all of those into a mixer and feed them back more or less, or control them distinctly frequency-wise and so on and so forth. Otherwise, we have the same options as always. We have something called an LFO, which in this case applies to the cutoff, as it says here. We have filters. We have LFO automation or modulation, rather. We have a global feedback control, and we have a mix knob. That's it. I can also, in this case, like I said, I have individual control over this, over the output of the different taps. So that's something which is not used that often for creating normal room-like effects or something, but it's rather for sound design purposes. Play around with it. And we also have, this looks kind of funny, but it's basically the same tools, right? We have actually 2 distinct delays in here, which are obviously mixed together in this unit. I have an analog delay mode. I have a grain delay mode, which are just different kinds of creating a delay effect. I have a time. I have a feedback. I have a pitch in this particular case, so to just pitch shift the whatever I feedback. Let's have a listen. See, pitch shifter, well, this is the size of the grains, and I have a mix knob per delay, basically the same in every device you're coming up with. So we actually at the end of our time, but I want to show you real quick how to build your own delay and how to achieve maybe different kinds of delay with simple tools built into something like HOFA system. Actually, the basic version of it is for free, so feel free to play around with it. Obviously, if you have a distance course at HOFA Studios or at HOFA-College, rather, you have the option to use this. Basically, what you need for a delay effect is, first of all, I already had it in there, a feedback module. So doesn't do anything with the sound, but I have a feedback knob. Whatever comes out of it gets fed back right into it. And obviously, you need a delay. This now doesn't do much, actually. It just delays whatever comes into there by whatever amount I type in here. I can also put it to notes. So now, as we don't have any feedback, it doesn't change the sounds at all, but see, it appears 16th later, which is exactly what a delay does, right? Without any feedback or something. So let me pull up the feedback and you will see what happens. Cool. Simple delay effect. And as we saw before, we usually have something like, let's say, an EQ. Shall we put in some EQ? Where is it? Usually it will get dollar over time, so let's put in that. Maybe even have some weird resonance here. And I don't like the lows of it. So when building your own delays, with a few clicks, as you can see, you have the option to choose whatever tone you like, basically. Let's say I want to make it a little more tape echo-like. Let's add a little bit of saturation then, or distortion, or something like that. I have a tape emulation here, let's put on that. This doesn't affect the direct signal going through here, but only the feedback chain. This means the signal gets fed back by 25%, so this means every iteration the signal part gets fed back, it will get a little more filter, it will get a little more saturation each time it goes through there. So each iteration of it will be a little duller and a little more distorted. This is kind of what happens in a tape echo as well, right? Sounds funny. I can also add a little bit of modulation to there, which is, as we saw before, something we'd find in many reverbs and ready-made tools, right? So this resonance is moving a little bit. Let's make it more extreme, maybe. Cool. And we could also use some pitch shift, maybe. So if I pull it up, oh, let's pick macro. This is a little more interesting. Each iteration of that gets fed back will be higher than the one before, right? Full octave here. Usually you choose something like this. And we can also modulate this, obviously. See? With 3 or, yeah, let's count that feedback as well. I used 4 modules and the knowledge I had in this workshop to build my own signature dub tape delay or whatever. And I can play around with this as much as I want. And basically all these simple features in here are all actually included in the free version of HOFA system. I think you only have one algorithm here for the saturator and so on. But basically you can build this your own And I'd rather do that in most cases, to be honest, than paying hundreds of bucks for a new plugin, which basically does exactly that with less control for my person. So that was really quick to how to build your own delay. Obviously, you could build your own reverb as well, but you'd, as we saw before, reverbs have much more complex patterns, and to achieve something that sounds real, like a real room or church or whatever, it will need a little more complexity in your signal chain. But basically, as it's the same functions, you basically have the option to build that as well. So hopefully that was helpful for you. Play around with it, play around with your delays, have a lot of fun sound designing, and hopefully you could learn something about perception of depth and perception of room in general, and how to use it in your mix. From time to time, as I said earlier, we also offer this workshop which is called Masterclass Reverb. And as I also said before, for all your German speakers out there, I will have this same workshop with maybe a little alternating context, because I always freestyle here a little bit. I will help tomorrow, so feel free to join there as well if you're familiar to the German language. And of course, this will be online for a couple of days or weeks or maybe months. So feel free to get back to it, repeat whatever you missed of this particular workshop. Thank you very much for tuning in. See you next time at HOFA-College. Have a nice day. Have a nice weekend when it's time. And of course, stay healthy. Bye-bye.